Up.
Okay, you ready? Alright. This is a demonstration video for a vacuum system that was purchased by the class group on purchase order number A1UA5-D11-B10. The intent of this is to go through and demonstrate the working machine. This is a second video. We had problems with the first video that was taken. DVD didn't seem to hang up. So we did some depositions during that run, and we're not going to repeat them as we're not set up anymore for them. But we do want to go through and demonstrate everything in working condition. First thing I want to do is go through and point out all the equipment as per our quotation N-8202-RT, which is what was purchased. First item is an 18-inch diameter by 30-inch tall stainless steel bell jar. The electric hoist is on the back side. The second item that was described was 1-inch custom painted frame enclosure. This is the custom painted frame enclosure. Front panels have been powder coated and have a nice durable finish on them. 1-inch VAT Series 64 servo drive high vacuum gate valve with PM5 controller. This is the PM5 controller. Inside that you can't see is the VAT valve. 1-inch CTI onboard cryogenic 8 cryo pump with soft key pad control. This is the soft key pad control. The CT8 is what you're hearing right now in the video. It's operational. It's down to temperature right now. The temperature is reading at 9 Kelvin. The 8510 compressor follows over here. It's right here. This is the CTI 8510 compressor. Right now it doesn't have the panels on the front or the back so you can see the operation. Next is the E2M40 mechanical vacuum pump, the 25 CFM vacuum pump. That is inside the cabinet here. We'll give a description once we remove the panels there later after we're done doing the demo. But the E2M40 pump is inside. This is the control for the pump. KF40 right angle bellows valve, roughing valve. That's the valve that is also underneath the cabinet here. That is our roughing valve, which is controlled by this switch here. 2 kVA transformer. All stainless steel manifold with multiple port base plate. Here's the base plate. The stainless steel manifold is underneath. 2 kVA transformer with multiple source holder for up to 3 filaments. This is the switch that controls. You actually have 4 positions. Number 4 is not connected, but we do have 1, 2, and 3. The transformer is located right behind this panel. Front panel, filament control with the ammeter. Here's your filament control. There's the ammeter. Granville Phillips 340 vacuum gauge with 1 ion and 2 convectrons. That's this device here. You have 2 convectrons. One is located in the bell jar. One is located in the roughing line. And the ion gauge is located in the bell jar area. Manually operated system with front panel controls. That's easy right here. There are switch control, so it's manual switch control. And these are the pilot lights as well as the switches. We'll demonstrate that as well. Okay, that goes through the system components. Now what we'd like to do is go ahead describe how this thing operates. First off, I'm going to go ahead and operate the mechanical pump. The mechanical pump is located up top. As you see, when you depress the switches, the pilot light will come on. The roughing valve is interlocked with the mechanical pump. That the roughing valve cannot open unless the mechanical pump is on. As you'll notice, in the roughing line, our vacuum pump has quickly come down to pressure 1.4 to -2, roughly 13-14 millitorr. Currently, we have the bell jar at 4.2 to the -2, which is roughly 42 millitorr. I'm going to go ahead and just demonstrate the opening of the rough valve and bring down the pressure to equal. What's unique to this system is the cryogenic pump that we're using. I believe previously in the class has used a diffusion pump system. Once we achieve our vacuum in the bell jar, we are going to shut off the rough valve and shut off the mechanical pump. Those are no longer needed to stay running. Unlike a diffusion pump, which is a throughput pump, it requires a vacuum pump. The cryo pump is a capture type pump, and it does not require, nor should it have, a pump operating as a core pump. They operate uniquely different. So as you see, our pressures are fairly equal. 1.2 times 10 to the -2 bell jar, and roughly 2.3 to the 10 to the -2 roughing line. They will eventually to allow them to. So for the sake of time, I'm going to go ahead and shut the roughing valve off, and then we're going to turn off the mechanical pump. They're no longer needed. We are currently at medium vacuum in this bell jar right now. What we wish to do right now, knowing that the cryo pump is cold, is open up our high vac valve. We are now at high vac, as witnessed by the bell jar convectron, which is now at 0. We will turn on the high vacuum ion gauge and see that it quickly is at 1.6, 1.5 times 10 to the -5. That pressure should rapidly go into the 6. But note that we are clean, dry, and empty right now at bell jar. Not have any product in there. Filaments are inside there. We do have some hardware down below, but we do not have the fixture inside. We also do not have any film inside. So our pressure is probably pumping a little bit more rapidly than you will see it when you run it with the product inside. Right now we're at 8 times 10 to the -6. If left pump alone, it should go down quite further. The plate vacuum system has been helium leak tested to 1 times 10 to the -8 standard cc's of helium. It is tight. We are not going to demonstrate that, but we will certify that on this video that it is leak tight. If it wasn't, we would be able to achieve the pressures that you're witnessing. What I'm going to do now is I'm going to leave this in filament position 2, and I'm going to turn on the evaporative power to show that what the process would look like if you had your film inside. At this point, you would turn up the controls, and you would see the amperage meter going up. What that is telling us is we're drawing current across the filament right now. I will bring it up camera. But as I said, we took some samples previously, and that's what we're going to send. The samples were done just as I'm demonstrating now. Unfortunately, the whole thing had some problems with the recording. That is the demonstration of the evaporative power. To change filaments, you simply pull the tab, rotate the filament in position, and drop it in. At that point, you will be on the second filament. You'll be able to run the second filament on. This one, I'm not sure if you turn it up. Is it glowing? Okay. And that's the second filament in there. Same for number 3. Simply rotating the number 3, and you would have the third position inside. We'll vent the chamber shortly to show that. We currently have a vote on number 2 and leave on number 2. Evaporative power. That's it, off and on, turn it up. The PM5 controller, let me explain how that operates. This is a servo drive high vacuum gauge, meaning it, or high vacuum valve, meaning it doesn't need compressed air to operate. It is controlled by the back valve. We have set this up to run remotely. As you notice, there's a light on the front that says remote. It's tied into this switch. If we push local and hold down local, it will go to local operation. At that point, you'll be controlling it from the open and closed position on the front panel of the controller. If you do it this way, you are bypassing this switch and the safety interlock, which does not allow you to turn on the vent valve unless this valve is closed. That's why we set that up that way. So to put it back in remote, operate the way we have designed it, you would hold it until the button is eliminated. Leave it in remote. It should stay there. To operate the gate valve, before I shut down the gate valve, we're at 3 times 10 to the minus 6. Previously, we operated this machine into the 7 range, which it would shortly get there if we allowed it to pump for a lot longer. But we've done some depositions since then. So I'm going to go ahead and turn off the ion gauge. You want to turn off the ion gauge as soon as you shut the high vacuum valve. That's to protect from inadvertently opening up the vent valve while the hot ion gauge is running. This time, simply de-energize the high vacuum valve and you will close the valve. It is in the closed position. It does tell you what the status is on the PM5 controller. So even though you're working this remotely, it is controlling the valve and telling you where you're at. Right now, our status is 9 Kelvin is on the cryo pump. All valves closed, all pumps off. We are going to go ahead and vent the chamber, raise the bell jar, and demonstrate. We have an interlock on the bell jar that keeps the hoist from raising or attempting to raise while it's under vacuum. The switch is set very lightly under vacuum, meaning that it has to vent to just about X. At that point, it'll allow it to go up. The vacuum switch is located underneath the bell jar, underneath the base plate through a feed through. It is an adjustable switch. If you ever have a situation where you need to readjust it, it is adjustable. We have set it. It should be more than adequate. One switch I did not describe while we're waiting for the bell jar to vent is the emergency stop that you see right here in red, labeled in yellow. Emergency stop is designed as a front panel disconnect basically for our controls. One thing should be noted, that the control transformer located down below here, which provides us 120 volt power, steps our 208 volts down to 120 volts, is constantly powered up. We recommend that you put in a separate disconnect outside of the machine, a 30 amp separate disconnect for this machine specifically. So when a service technician needs to service the bottom end and wants to be assured that the power is down, disconnect the power. You can also use the twist lock cord on the back to completely disconnect the power. But as soon as we are vented, I will demonstrate how the emergency stop operates. Currently we're at about 7.6. Bang on the barometric pressure, you can reach it here, 7.8. Shut it down, you see all the power goes down. Now this will stay powered up because this gets its power remotely from the compressor, and it is no more than tied in a simple ribbon cable tied into the compressor itself. So as the cryo pump is still running, we need to shut down the compressor, which is on separate power supply. When you re-engage, you simply twist turn, everything should come back to the last status where it was, including the evap valve, which it has. It's in the closed position, it is vented, and now we're ready to open the bell jar. The hoist is located, our labels are here showing clearly the up and the down position. Auto stop feature. As you see, I have not let go of the switch. That allows us to do that.
Oh, okay.
Why don't we zoom in here? You can see we have a little bit of coating that was done inside the bell jar here. What you have here is some aluminum in the center boat. These are the three positions that are currently in use. That's what we have hooked up. There is a fourth position here, but it would require a little bit more hardware. We are providing the feed-through. What you see over here is our vacuum switch that's into the base plate. You still have one feed-through over here, one feed-through here, one feed-through here. Those are blanked. In addition to the top plate of the bell jar has a blank plate that could be modified to accept fixtures or tooling from up top, such as a film thickness controller, that type of stuff. Okay, so from this position, you have loaded your hardware inside. We have modified the tooling that was provided, and we simply, on our deposition run, we simply sat it inside. We had the film attached around, and we did our deposition. What I'm going to do now is just go ahead and drop down the jar and do another pump down. Okay, down position. Again, automatically stops. Gets down to lock position. At this point, I'm going to repeat the process that we did before. Our red, white, and blue switches in order. So we turn on our mechanical pump. pressure in a mechanical pump. And we'll go ahead and turn on our light, which is our rough valve. We previously did the demonstration. I think our pump down cycles were about 2 to 3 minutes.
2.5.
2.5 minutes.
3 minutes.
And that is to a crossover pressure of, I believe it was 1 times 10 minus 1, which would be roughly 100 millitorr. We recommend at least 100 millitorr crossover. You can go a little bit higher. It'll increase the requirement for the regeneration times between the cryo pumps before you cryo pump 100. So use the 100 millitorr as a benchmark. I think you'll be okay. Cryogen pumps. Well, I got an opportunity here. The way you run your cryo pump, as I explained earlier, is it's a capture pump. It takes approximately an hour and a half to get cold, 2 hours to get cold. And when it gets cold, you're best letting it run, continue to run, if possible. That's typically the way they're designed to operate. Once they are cold, you just leave them be, go home at night, have you come in the morning, operator, now may start the machine. If the machine is going to be down for long runs, long periods of time, what you want to do is you want to go into a regeneration mode. What that means is, and this is a fully automated system, regeneration will actually bring the cryo pump up to temperature, it'll bring it up to roughly 300 Kelvin. Brings it up to temperature with heated gas, has internal heaters inside to do this. You'll use dry nitrogen gas to do this. When it brings the temperature up, it will actually be purging nitrogen through the cryo pump. The reason we do this is to dry the cryo pump. Inside the cryo pump, we have charcoal. The charcoal is used to absorb the non-condensable gases. What also happens is the charcoal absorbs the moisture inside the chamber. Every time you cycle the chamber, a little bit more moisture gets down. Regenerating it basically dries the charcoal, makes the pump more efficient, dispels all the gases in there that need to be dispelled, and it regenerates it back to the point where you can bring it home. So if you're going to shut down the cryo pump system for, say, a long weekend or a week and you're not going to use it, run a regen, have it ready to go, leave it in that status, shut it off. It'll stay under vacuum, it'll stay dry, then when you're ready to go, the regen cycle that it goes through before you start up really quickly, and as you hear it, that's the way it should operate. Right now we are down to back pressure, 2.7 times 10 minus 2. Again, turn off the rubbing valve, turn off the mechanical pump. As you see, the rubbing valve is interlocked, it will not operate. Safety feature. Now we run the high vacuum valve, as we did before, and the whole cycle is repeated. On with the ion gauge, and we are down in the low 10 to minus 5 range. Instantaneously. That concludes our demonstration of the operation of the high vacuum system. What we'd like to do is we'd like to take off some panels and show you the hardware inside. So we're going to go ahead and stop the tape right now and take the panels off so we can show you the insides and some of where the hardware is. Alright, we're back. I just realized I didn't introduce myself. My name is Bob Tombrello. The name of our company is Associated Vacuum Services. What we're going to Hi there. Again, my name is Bob Tombrello, Associated Vacuum Services. What we're here to show you is some of the components located underneath the cabinet that you can hear operating, but now we're going to show you. What we have here first is our Edwards high vacuum pump. It's a 25 CFM, 2-stage rotary vacuum pump. We've included a high efficiency oil mist eliminator built right into the cabinet. We have raised the pump so it clears the caster height and put this on a maintenance cart. So you have a custom built maintenance cart here with locks. To service this pump, you would simply twist lock, unplug, disconnect this connection here, which is your intake connection, and wheel out for draining oil, servicing, whatever you need to do. Everything that was done was with maintenance in mind. Some of the components inside here is you have a flexible bellows line to minimize the vibration. Again, they're on two separate carts. The pump is sitting by itself on its own lock wheel cart. The rubber casters, and very little vibration happens. But this is to kind of take out some of that slack. You have your custom stainless steel manifold inside here, which includes a convectron gauge. You may be able to see the gauge back there. The roughing valve is in the back, and that's our roughing valve that we control from the front with the white button. You also have up front here the back of the 22mm push button switches. Our two components, which are the Granville Phillips gauge and the PM5 controller. Over here is our electrical systems. We have a fuse bank here of 3 fuses. We have a 110 volt power strip in there. Vacuum pump that's on a twist lock plug for disconnecting for maintenance. It's also controlled by a starter. We have a couple of contactors, one being a main contactor, another being a evaporative power supply contactor. This is our that valve that we're supplied. That is the servo control motor up on top, and it uses a control cable to drive it. As you can see, it's very clean, everything is very organized inside. What you hear operating now is the cryo pump in the back, and we'll go over to the other side to take a look at that. Out the front of the machine, as I had mentioned earlier, is we do have one section here that will be a constant power, and that is marked on there, live power, 208 volts, and it is a constant even with the stop switch turned off. This is our 2 kVA transformer located in the front. This is a low voltage transformer. It does have some taps. We're operating on a 5 volt tap right now. If you needed to change the tap, you would have to actually physically change it. What we have on this side here is our hoist motor control. It has a reduction gear drive motor in it. You want to take note that of the gear drive. This is the CTI cryogenic pump. This is the CT8. The onboard pump here has a control down below, which is the heart of it. Okay. And then we have the ionization gauge up top. Here's your vacuum switch. I think we're pretty much running out of tape now, so we're going to conclude this if we cut off short.